Hi, welcome to Educator. This is Teacher Jeff. I'm an educator and an engineer by profession. And today we will discuss Chapter 3. And Chapter 3 is all about operations analysis. And in today's lesson, there are 9 key areas that I'm going to be highlighting today. First, we have the introduction to lean manufacturing. Second, we will be discussing the operations purpose. Third, we have part design. Fourth, we have tolerances and specifications. We also have material, manufacture sequence and process. Sixth, we have the setup and tools. Seventh, we have material handling. Eighth, we have plant layout. And finally, we have work design. Now, in order for us to get started, let us discuss first our first key area of our lesson, and that would be the introduction to lean manufacturing. Now, take note that methods analysts use operation analysis to study all productive and non-productive elements of an operation to increase productivity per unit of time and to reduce unit costs while maintaining or improving quality. Now, when properly utilized, methods analysis develops a better method of doing the work by simplifying operational procedures and material handling and by utilizing equipment more effectively. And therefore, firms are able to increase output and reduce unit cost. And to ensure quality and reduce defective workmanship and facilitate operator enthusiasm by improving working conditions, minimizing operator fatigue, and permitting higher operator earnings. Now, as we learned in Chapter 2, operation analysis is the third method step, the one in which analysis takes place and the various components of the proposed method crystallize. Now, it immediately follows obtaining and presenting facts using a variety of flow process charting tools presented in Chapter 2. Now, the analyst should review each operation and inspection presented graphically on these charts and should ask a number of questions, the most important of which is why. Okay, so the first question that the methods analyst should ask would be, why is this operation necessary? Okay, you need to understand and you need to determine why this certain operation is necessary. Second, why is this operation performed in this manner? Okay, is this certain operation performed manually or by the use of machine? Third, why are these tolerances disclosed? Because there are some tolerances that are close enough or that are far away from each other. And fourth, why has this material been specified? And finally, why has this class of operator been assigned to do the work? Now, the question why immediately suggests other questions, including how, who, where, and when. And therefore, the analysts might ask, how can the operation be performed better? All right. And second, who can best perform the operator? And third, where could the operation be performed at a lower cost or improved quality? And finally, when should the operation be performed to yield the least amount of material handling? Answering these questions actually helps initiate the elimination, combination, and simplification of the operations. And also, in obtaining the answers to such questions, analysts become aware of other questions that may lead to improvement. Ideas seem to generate more ideas, and experienced analysts usually arrive at several improvement possibilities. And take note that analysts also must keep an open mind so that previous disappointments do not discourage trying new ideas. Such opportunities for methods improvement usually appear in every plant with consequent beneficial results. And note that much of the information presented in this chapter is currently used in a repackaged format termed as lean manufacturing. So, what do we mean by lean and lean manufacturing then? If we say lean, it is defined as a set of management practices to improve efficiency and effectiveness by eliminating waste. The core principle of lean is to actually reduce and eliminate non-value adding activities and waste. Now, take note that the customer defines what is of value in terms of what they would pay for the product or service, correct? Through lean management, what adds value becomes clear by removing or reducing everything that does not add value to your product. And on the other hand, if we say lean manufacturing, it is also popularly known as lean production. And lean manufacturing or lean production is a methodology that focuses on minimizing waste within manufacturing systems while simultaneously maximizing productivity. Now, in other words, it is actually a system of techniques and activities for running a manufacturing or service operation. And take note that these techniques and activities differ according to the application at hand, but they have the same underlying principle, which are the elimination of all non-value adding activities and waste from the business. So to not take full advantage of all your resources is to lose efficiencies and in so doing, stunt production. And these neglected resources includes everything from manufacturing project management tools to the skills of the staff members. And industry is, of course, rife with waste, correct? Now, whether it's idle workers or maybe unused materials that cannot be recycled or repurposed, the results are the same, a drag on productivity. So this insistence on eliminating waste is where the idea of lean as a management systems develop. Now, called lean manufacturing or lean production, the truth is that the lessons learned from this methodology can be universally applied, meaning lean manufacturing principles can help your business processes gain efficiencies and as a result, become more effective and competitive in any marketplace. So even if you're not in the manufacturing business, okay, you can still learn something from this methodology that changed the world. Now, in order for us to better understand what lean manufacturing is all about, then we need to discuss the history of lean manufacturing. Now, as you can see in our presentation, Teiichi Ono was a Japanese industrial engineer and businessman who worked for the Toyota Motor Company from 1943. And he is responsible for what is known as the Toyota Production System, or the TPS, within which he devised many improvement frameworks, including the 7 wastes or mudas in Japanese. Now, muda means futility, uselessness, idleness, superfluity, waste, wastage, wastefulness. Okay, so those are the definitions of mudas. And if we say muda, it is just one of the 3 types of issues Teiichi Ono identified as deviations from the optimal allocations of resources. Now, the other 2 are mura, or unevenness, and muri, or overburden, which we will be discussing in detail later on. Now, the idea of lean manufacturing was actually first championed by the Toyota Production System, or the TPS, and called lean in the 1990s. And this coincided with the growth of Toyota from a small company to one of the world's most successful seller of motor vehicles. Now, lean manufacturing was actually introduced to the Western world via the 1990 publication of The Machine That Changed the World, okay? As you can see on the sample picture, and which was based on an MIT study into the future of the automobile detailed by Toyota's lean production system. Now, since that time, lean principles have profoundly influenced manufacturing concepts throughout the world, as well as the industries outside of manufacturing, including healthcare. We have software development and even service industry. But lean as an idea encompasses reduction of waste goes back to Benjamin Franklin, who wrote about it in his Poor Richard's Almanac essay, The Way of Wealth. Okay, as you can see on the right portion, that is the a book that was written by Benjamin Franklin entitled The Way to Wealth. And he noted that avoiding unnecessary costs could be more profitable than increasing sales. And this idea and other relevant concepts appear in his essay, The Way to Wealth. And the idea grew into what mechanical engineer Frederick Winslow Taylor called scientific management, which analyzes and synthesizes workflow to improve efficiencies. And in his book, Principles of Scientific Management, published in 1911, he codified the process. The term lean as a principle of manufacturing was first used by John Krafcik in the article Triumph of the Lean Production System, which was published in 1988 and based on his MIT Sloan School of Management master's thesis. Now, Krafcik worked as a quality engineer for a joint venture between Toyota and General Motors in California before he earned his master's degree. Now, if you might be asking, how do we practice lean manufacturing then? Well, to answer that question, the general meaning of lean is that it consists of a set of tools that help to identify and eliminate waste. Now, in simple terms, lean manufacturing requires a relentless pursuit of reducing anything that does not add value to a product, meaning waste. So that waste can be created through an overburden and unevenness in workloads. And the removal of waste from any system improves quality and production time while reducing costs. So this makes continuous improvement or Kaizen, which lies at the heart of lean manufacturing, a must. Now, in order to practice lean manufacturing, we need to be reminded or we need to be acquainted of the different tools and concepts of lean manufacturing. Some of the lean tools and concepts that are very important and useful in this study, we have Hijunko. If we say Hijunko, it is a Japanese word which means production leveling or smoothing that seeks to produce a continuous flow of production, releasing work to the plant at the required rate and avoiding interruption. Okay, as you can notice, that is an example of Hijunko. Okay, they have their Hijunka pose. They made this available in order to somehow level the production, okay, or to smoothen the production level. And second lean tool and concept that we have, that is what we call 5S, okay? So 5S, we have a first seri, or meaning sort, seton or straighten, we have seiso or shine, we have siketsu or standardize, and we also have shitsuke or sustain. If we say seri or sort, it means to separate necessary items from unnecessary items. Okay. Now, if we say Satan or straighten, what we do here is to make a place for everything, and everything must have a proper place. And if we say so or shine, it means cleaning up as you work and maintain a clean environment. If we say siketsu or standardize, we need to develop rules to repeat positive results. And finally, if we say shitsuke or sustain, it means maintain consistency and strive for continued improvement. Now, actually, 5S can be applicable in offices as well, not just in manufacturing, but also in office setting. Now, if we say 5S, it is actually a set of practice for organizing workspaces to create efficient, effective, and safe areas for workers, and which prevent wasted effort and time. So 5S emphasizes organization and cleanliness. So as you can see there in our sample pictures, you have there a before, comparison of before and after. So as you can notice, the first picture isn't really organized, okay? The things are not sorted out from which is necessary, which is not. On the second picture in the after, so it's very obvious that it is already arranged properly. It is already sorted out properly, all right? And it's also clean and organized compared to the first picture. So that is the idea of 5S. And another lean tool and concept that we have, that would be Kanban boards. So what do we mean by Kanban boards? So as you can see on our sample pictures, you have their stories, okay? So you have to-dos, what you need to do for today. So the list of things, you need to list down all the things that you're going to be doing today. So once it's done, so it will be posted as in progress, okay? And once it's completed, then you need to do testing. And once it's done testing, then it's already finally done, okay? So that is what we call Kanban boards. So definitely, if we say Kanban board, it is a signal used to streamline processes and create just-in-time delivery. So just like what we did here in our example, we streamline our processes, and so we would be able to create just-in-time delivery. And it also signals can either be physical, such as a tag or empty bin, or electronically sent through a system, okay? And another lean tool or concept that we have, that is what we call Jidoka. And if we say Jidoka, it is a method that defines an outline for detecting an abnormality, stopping work until it can be corrected, solving the problem, then investigating the root cause. Now, as you can see on our first picture, the man was manually feeding and watching machine cycle. And on the second, or the middleman, is watching machine cycle. And on the third picture, you have there self-monitoring machine. So there's no man anymore. So what is being done here? They included another system. That's what we call andon system or andon lighting, and it helps signals automatic feeding and automatic injection as well. Now, as you can see in our second example, you have there operation number 10 and operation number 20. And as you can notice, in between them, you have there what we call limit switch, meaning to say you cannot add additional materials on the conveyor if there is still a pending or queuing materials to be communicated to the next process, okay? So that is what we call limit switch. So if we say Jidoka, in simple terms, Jidoka helps detect any abnormality in our process. So if there is any abnormality in the process or procedure, then there will be a stoppage of work until it can be corrected. All right. And another lean tool and concept that we have, that is what we call POCA UK. So if we say POCA UK, it is a term that originated in Japan, which means mistake proofing, and is concerned with preventing errors from becoming defects before the fact. So in other words, POCA UK is about prevention of errors. So as much as possible, you need to prevent any error or in order to avoid product defects. Okay, so in order for us to better understand what POCA UK is all about, so as you can see, this is an example of a POCA UK. So in our first example, you can see there a SIM card. So there is a word there at the upper part portion, confusion. Why confusion? Because there is no indication as to where you're going to be tearing that certain paper where the SIM card is inserted. So in order to apply POCA UK, you have there clarity, meaning to say you indicated a slight portion in the upper right corner of the paper in which the SIM card is being inserted. And so it will be very easy for you to tear it. Okay. So in another picture, okay, in my right portion, you can see there a car. Okay, you have there a red car and a black car. Now, as you can notice, in the red car, you have their standards inside the car, which detects error as well. So you have there collision warning and brake support. So in order for car manufacturers to avoid any collision, okay, so between two cars, there is what we call a detector to avoid collision, okay? So to detect collision warning and brake support as well. Aside from this, we have 4 examples of POCA UK. First, we have pick by barcodes. Second, we have pick by light. Third, we have pick by voice. And fourth, we have undone system. Now, in order for us to better understand each of these examples, let us discuss them one by one, starting with pick by barcodes. So what do we mean by pick by barcodes then? If we say pick by barcode, this is actually a method which utilizes barcodes and an optical barcode scanner. So a terminal provides the operator with real-time data collection information about where they need to go, what they need to pick, and in what quantity, using either text or images. Now, as you can notice in our example, the operator uses the device to scan the barcode on the storage box, and the terminal provides them with information regarding the desired quantity. So the barcode scanner and terminal are either handheld, secured around the lower arm, or truck mounted. So this system tends to be more cost effective than pick by light in lower volume environments. However, unlike other picking systems, the operator needs to look at the screen to retrieve the necessary information, which can be an inconvenience. So this system is considered to be one step up from using a paper sheet to carry out picking tasks. However, it is not suitable for certain work environments when operators need to wear protective clothing, such as gloves. And aside from pick by barcodes, another example of POCA UK is what we call pick by light. So pick by light is a method which uses lights positioned on shelves, as you can see in our sample image. Like I said earlier, this method uses lights positioned on shelves, floor racks, or workbenches to direct and indicate to the operator what they should do next. Now, at the right point in the sequence, the light will guide the operator to certain location. And once we have completed the task, the light will either go off automatically based on sensors, or the operator will manually confirm the action by clicking the illuminated button, triggering the next light in the sequence to illuminate. So in addition to a light, some systems are fitted with a display showing the necessary quantity or other information. And another example of Boca UK is what we call pick by voice. Now, this system is similar to pick by light, but it uses the sense of hearing to gain the operator's attention rather than lights. So as you can notice, each operator wears a headset and is provided with the necessary information to know what to pick, in what quantity, and where it is located. So in this method, both the user's hands and eyes are free. And to confirm the pick, the operator can use voice control where they will repeat some of the product information. For example, it may be the last four digits of the barcode and so on. Or maybe a sensor positioned in the container will detect their selection. So unlike pick by light, this technique can be used even when multiple operators are working in the same area. So the use of both pick by voice and pick by light make it relatively easy for new workers to learn their new work tasks quickly. And the last example of Poka Yoke is what we call the Andan system. So as you can notice, Andan system provides a visual display that all workers can see to show the status of the plant floor or the production line. So enhanced visualization is said to not only create a sense of belonging in teams, but also point out when problems in the process occur, alerting management, maintenance, and other workers down the line who depend on the affected station. So empowering operators to stop the production processes actually encourages an immediate response, which in turn should enhance the overall quality and reduce waste. So generally speaking, here, the worker at the directly affected station pulls a cord triggering an alarm or flashing lights to alert the rest of the workforce that a problem has occurred. And this can also be automated. And once the issue has been resolved, the undone is deactivated so that work can continue as normal. Many industry facilities have undone coaches whose role is to resolve any issues as soon as they arise. And finally, another lean tool and concept that is very important, that would be cycle time. In this concept or tool, we would be asking ourselves how long it takes to produce a part or complete a process. Now, another way to approach lean manufacturing is called the Toyota way, as it was developed by the company. So in here, the focus is on improving workflow to remove unevenness as opposed to wastefulness. So Kanban is essential for this type of lean management. And the goals for both approaches are the same, but the means to achieve it are slightly different. So in the Toyota way, improving workflow is the goal, but in so doing, waste is also eliminated naturally. So proponents of this process state it takes a system-wide perspective as opposed to one solely on waste removal. Now, as you can notice in our example, you need to understand the differences between different times. So in manufacturing or production, we have what we call takt time, we have cycle time, and we also have lead time. Now, according to machine metrics, takt time formula that would be workable production hours all over units required or customer demand. So in simple terms, if we say takt time is the rate at which you need to complete 1 unit of output in order to meet customer demand. On the other hand, we have cycle time. And cycle time's formula, that would be the net production time divided by the number of units produced. In other words, if we say cycle time, it is the time it takes to complete the production of one unit from start to finish. So the difference between takt time and cycle time is that takt time is based on customer demand, whereas cycle time is based on process. Now, as you can see in the example of on my left side corner, you have there cycle time, okay? As you can notice, a cycle time starts from the beginning of the manufacturing up until the end of the manufacturing. So therefore, cycle time is the time it takes to complete the production of one unit from start to finish. And finally, we have lead time. And lead time is equal to order delivered minus order received. In this case, this lead time that I'm referring to is once you have delivered your finished product to your customer, then the lead time computed will be from the delivery up until the receipt of the product by the customer. So that's what lead time that I'm referring to in this particular example. All right, so those are the different lean tools and concepts that we should need to be acquainted to, because these lean tools and concepts are very helpful, especially if we want to eliminate or reduce manufacturing wastes or mudas. Now, moving on to our next subtopic, that would be the principles of lean. Now, take note that a widely referenced book, Lean Thinking, Banish Waste and Create Wealth in Your Corporation, which was published in 1996, laid out 5 principles of lean, which many in the field reference as core principles. So they are the value stream, flow, pull, and perfection. So these are now used as the basis for lean implementation. Now, the first principle of lean is what we call identifying the value from the customer's perspective. Now, what do we mean by this? If we say identifying value from the customer's perspective, what I mean about this is that value is created by the producer, correct? But it is defined by the customer. And therefore, companies need to understand the value the customer places on their products and services, which in turn can help them determine how much money the customer is willing to pay. And the second principle of lean is map the value stream. Now, in mapping the value stream, this principle involves recording and analyzing the flow of information or materials required to produce a specific product or service, with the intent of identifying ways and methods of improvement. Now, value stream mapping encompasses the product's entire life cycle from raw materials through the disposal. So in this case, companies must examine each stage of the cycle for waste, and anything that does not add value must be eliminated. So lean thinking recommends supply chain alignment as part of this effort. And the third principle of lean is what we call creating flow. And in creating flow, what we need to do here is to eliminate functional barriers and identify ways to improve lead time. And this aids in ensuring the processes are smooth from the time an order is received through delivery. So flow is critical to the elimination of waste. And therefore, lean manufacturing relies on preventing interruptions in the production process and enabling a harmonized and integrated set of processes in which activities move in a constant stream. And the fourth principle is what we call establish a pull system. Now, this means you only start new work when there is demand for it. Meaning to say, lean manufacturing uses a pull system instead of a push system. Now, push systems are used in manufacturing resource planning or MRP systems. So, with a push system, inventory needs are determined in advance and the product is manufactured to meet that forecast. However, forecasts are typically inaccurate, which can result in swings between too much inventory and not enough, as well as subsequent disrupted schedules and poor customer service. Now, in contrast to MRP, lean manufacturing is based on a pull system in which nothing is bought or made until there is demand. So, pull relies on flexibility and communication. And finally, the last principle of lean is what we call pursuing perfection with continual process improvement or kaizen. Now, here, lean manufacturing rests on the concept of continually striving for perfection, which entails targeting the root causes of quality issues and ferreting out and eliminating waste across the value stream. But also, we need to bear in mind that Toyota maintains that lean's main thrust is not the tools, but the reduction of three types of waste: non-value adding work, in Japanese called muda, overburden or mori, and unevenness or mura. So it is through these means that lean helps productivity and it simplifies operational structure to understand, perform, and manage the work environment. So to do all this at the same time, Toyota applies a mentoring methodology called senpai and kohai, which translates to senior and junior. So this fosters lean thinking throughout an organizational structure from the group up. Now, in order for us to better understand the three types of waste, so we will now discuss the types of wastes in lean manufacturing. So as mentioned earlier, we have three types. First, we have mura. Second, we have mori. And third, we have muda. Now, in order for us to better understand each of them, let us discuss them one by one, starting with mura. So what do we mean by mura then? If we say mura, it means unevenness or waste due to fluctuations in demand. So this can come from customer requests, but it can also be due to an organization adding new services and thus additional work. So that makes your process uneven. And second, we have mori. If we say mori, it means overburden or waste due to trying to do too much at once. So this means that this has to do with resource allocation. So when too few people try to do too much work, they often waste time switching from one task to another. So that makes them overburdened workers. And third, we have muda. And if we say muda, it means non-value adding work or process waste. So in other words, this waste comes as a byproduct of something else. So think about three things. Okay, think about value, works that adds immediate value for a customer, necessary waste, which are supporting activities that add value, and unnecessary waste or activities that do not add value. So therefore, lean maximizes value, minimizing necessary waste, and removes unnecessary waste altogether. And therefore, we conclude that in general, the goal of TPS or Toyota Production Systems is to actually eliminate these three types of waste in manufacturing. And the goal is to design a process that runs smoothly, can flex without stress, and eliminates waste as well. Now, in order for us to better understand the 8 manufacturing wastes or mudas, we will now be discussing them one by one, starting with transportation. But before that, please be reminded that the 8 wastes of lean manufacturing are what we are aiming to remove from our processes by removing the causes of Mura and Muri, as well as tackling Muda directly. So, but what exactly are the 8 wastes of lean manufacturing or Mudas? Now, the 8 wastes, as you can see, we have the waste of transportation, the waste of inventory or excessive inventory, the waste of motion or unnecessary motion, the waste of waiting, the waste of over processing, the waste of overproduction, the waste of defects, and lastly, we have the waste of skills and utilize. So, as industrial engineering students or as professional industrial engineers, we need to memorize these types of manufacturing wastes by heart because this is actually our main job. This is one of the many reasons why we exist and why businesses need our help. So, how are we able to remember these types of manufacturing wastes or mudas then and try to not forget them? Well, actually, there are a couple of simple mnemonics that you can use to help you remember the 8 wastes. And the first to ask yourself is, who is Tim Woods? And the second way to ask yourself is, what is downtime? Okay, so these 2 mnemonics would be of great help for you in order for you to always remember the 8 wastes of manufacturing. So in Tim Woods, so you have there the abbreviation Tim Woods. T stands for transportation, I stands for inventory, M for motion, W for waiting, O for over processing, O for overproduction, D for defects, and S for skills unutilized. And the other way to remember the 8 wastes, that would be the word downtime. So D stands for defects, O for overproduction, W for waiting, N for non-utilized talent, T for transportation, I for inventory, M for motion, and E for extra processing. So what exactly is a waste then? Well, the simple way to describe waste is something that does not add value. So how often have you used the expressions, that was a waste of time, that was a waste of money, that was a waste of effort? Now, perhaps a lot of time, correct? Even myself, I've used those expressions a lot of time already. And take note that our customers would not be happy to pay for any action that we take that does not add value to what they actually want, and nor should we be, right? So, since you are a customer, if I were to ask you, do you think you would be happy if you received a bill in a restaurant that included a meal that was prepared in error? Of course not, right? Instead, you would argue and demand that it was removed from your bill. Yet, if you buy a product in a store, the price that you pay will contain costs that you would not want to pay. Another thing I would ask you, supposing you own your own company, okay? So would you want to pay for the machine operator's wages while they sat idle waiting for a delivery, or for the rework processes that had to be undertaken because the machine was incorrectly set, or even for storing your product for 3 months before it was delivered to the store? Of course not, right? So these wastes are included within the costs of your products, either inflating the price you pay or reducing the profit of the company. So why do we remove waste then? Now, we remove waste in order to increase companies' profits. So what do we mean by this? So remember, Your company's profit is your selling price less your costs, right? No matter how you think about the selling price, it is very much dictated by the market and not by yourself. So if you charge too much, then your customer will go elsewhere. Even if you charge too little, you may lose customers as they will perceive there may be something wrong with what you are offering. So, therefore, the only way to improve your profits are to reduce your costs. So, this means removing all elements of waste from your processes. And the second reason why we need to remove waste is because waste has a major impact on your customer satisfaction with your products and services. So, in addition to improving your profits, you will find that waste has a major impact on your customer satisfaction with your products and services. So, your customers want on time delivery, perfect quality, and at the right price. So, something that you cannot achieve if you allow the eight wastes to persist within your processes. So, what do we do to eliminate wastes then? Now, we first need to identify what is and what is not a waste. Then we can look at ways at eliminating or at least reducing waste. So, in identifying waste, take note that there are two types of activities. First, we have value added activities. And second, we have non value added activities. So, what's the difference between the two then? If we say value added activities, these are activities that change the form, fit, or function of a product or transaction, or something customers are willing to pay for. So, in short, this is where we make profit. On the other hand, for non value added activities, these are activities that absorb resources but adds no value is a waste. And all other actions and unwanted features are by definition waste. So, in short, this is where we make a loss. So, that being said, our primary objective is to raise the ratio of value added activities to non value added operations and eliminate wastes. Now, in order to do this, we need to apply different lean manufacturing tools and concepts. Now, in order for us to better understand each of these manufacturing wastes or mudas, let us discuss them one by one, starting with the waste of transportation. Now, what do we mean by the waste of transportation then? If we say transport, it is the movement of materials from one location to another. This is a waste as it adds zero value to the product. Examples of waste of transportation that would be materials movement, unnecessary moving or handling of parts, handling equipment moving with no parts, raw materials batch sizes not matching production batch size, and finally we have materials stored a long way from point of use. Now, why would your customer want to pay for an operation that adds no value, right? So transport adds no value to the product. So you as a business are paying people to move material from one location to another, a process that only costs you money and makes nothing for you. So the waste of transport can be a very high cost to your business, and therefore you need people to operate an equipment such as trucks or fork trucks to undertake this expensive movement of materials. Now, in order for us to better understand why unnecessary transportation is considered a waste, let me give you an example. Okay, this is our sample scenario. So, supposing Edgar, a master baker who is working in a commissary of a certain renowned bread, cake, and pastry industry, travels 35 feet from his workstation to the oven station 32 times per day. And take note, the average walking pace of Edgar is 0.227 seconds per foot. And 0.227 seconds per foot multiplied by 35 feet, okay, that would be 7.9 seconds per trip. And 7.9 seconds per trip multiplied by 32 times per day of travel, that becomes 252.8 seconds per day. And 252 seconds per day multiplied by 260 working days in a year. So that becomes 18.30 hours per year. And 18.30 hours times $20 per hour. So that would be $366 per year spent by Edgar to travel to the oven station. Take note, that is very costly, right? $366 per year just for the transportation is a lot of money already. So therefore, in order to solve this, if stations were 6 feet apart, then the amount paid to walk to next station would only be $63 instead of $366. Okay? So that is now the reason why we need to eliminate or reduce the waste of transportation. Another waste is what we call the waste of inventory. If we say inventory, it makes control difficult and obscure the opportunity for improvement. It delays actions in dealing with faults and defects. It reduces need to face up to fast tool changeover. It imbalances in capacity capability. Goods can become damaged or obsolete, creates unnecessary searching and movements of materials, takes up space. Now, this being said, it is very clear that inventory costs you money, right? So why is that? Because take note that every piece of product tied up in raw material, work in progress, or finished goods has a cost, and until it is actually sold, that cost is yours. Now, in addition to the pure cost of your inventory, it adds many other costs. So inventory feeds many other wastes. Inventory has to be stored, and take note that since it has to be stored, then it needs space, right? And since it needs space, it needs packaging, and it has to be transported around. And since it has to be transported around, it has a high chance of being damaged during transport and becoming obsolete as well. And therefore, the waste of inventory hides many other wastes in your system. Now, in order for us to better understand why inventory is considered a waste, then let me give you an example. So, for example, okay, so as you can see, this is an example of the waste that is being hidden by the waste of inventory. So you have there the C of inventory. So you have long setup times, quality problems, supplier issues, you have employee availability, long transportation, machine downtime, communication problems, and so on and so forth. Like I said earlier, your waste of inventory hides many other wastes in your system. Now, in order for us to better understand this, let me give you a scenario. So, for example, ABC Corporation rents a warehouse space to hold its inventory. Now, since you need to rent a space because you don't have enough space in your company to hold your inventory, so it needs 40,000 square feet to hold your inventory, and your warehouse space costs $4 per square foot per month. Now, in solving this, 40,000 square feet multiplied by $4 per square foot per month, that would be $16,000 per month. And $16,000 per month multiplied by 12 months in a year, so that would be $192,000 per year just for your storage. And take note, $192,000 is a lot of money already. So that is why we need to understand, okay, we need to make sure that we are able to eliminate or reduce the waste of inventory. Another example of manufacturing waste or mudas that we need to eliminate or reduce, that would be the waste of motion. So if we say unnecessary motion, these are those movements of men or machine which are not as small or as easy to achieve as possible, bending down to retrieve heavy objects at floor level when they could be fed at waist level to reduce stress and time to retrieve. Now, by this, I mean bending down to retrieve heavy objects at floor level when they could be fed at waist level to reduce stress and time to retrieve. So, excessive travel between workstations, excessive machine movements from start point to work start point are all examples of the waste of motion. So, all of these wasteful motions cost you time or money, and the cost stress on your employees and machines. After all, even robots wear out. Now, if I may ask you, how often do you spend time waiting for an answer from another department in your organization, or waiting for a delivery from a supplier or an engineer to come and fix a machine? So we tend to spend an enormous amount of time waiting for things in our working lives, correct? May it be our personal lives too. So this is an obvious waste. Another, if we say waste of waiting, it disrupts flow, one of the main principles of lean manufacturing. As such, it is one of the more serious of the eight wastes or mudas of lean manufacturing. So, in order for us to better understand waste of waiting, let me give you an example. So, this is an example of muda of waiting or waste of waiting. As you can see on the sample picture, the man is waiting for the machine to finish, right? This is definitely should be eliminated or reduced. Now, in order for us to better understand the muda of waiting, let me give you an example. So, for example, an employee waits 20 seconds for previous operation to finish each part. Now, take note that 20 seconds multiplied by 60 parts per hour, so that would be 20 minutes per hour spent waiting for parts, right? And 20 minutes multiplied by 8 hours per day, okay, supposing your working day or working hours in a day rather is 8 hours. So that becomes 2.67 hours per day just spent for waiting. And 2.67 hours multiplied by 260 days in a year, so that becomes 694.4 hours per year spent waiting. And 694.4 hours multiplied by $20 per hour, so that becomes $13,888 spent on employee waiting for previous operation. Okay, as you can notice, $13,888 is already a lot of money, and therefore we need to really eliminate or reduce the waste of waiting. Another example of manufacturing waste or muda, that would be the waste of overproduction. If we say overproduction, it is the worst kind of waste ever because it causes other kinds of waste and obscures the need for improvement. And it also results from producing more or faster than what is required. And it caused by large batch sizes, unreliable processes, unstable schedules, unbalanced cells or departments, or working to forecast or inaccurate information, not actual demand. So the most serious of all of the eight wastes is the waste of overproduction. And it is making too much or too early. So this is usually because of working with oversized batches, as mentioned earlier, long lead times, poor supplier relations, and a host of other reasons. So overproduction, therefore, leads to high levels of inventory, which mask many other problems with your organization. So what should be our aim then? So the aim should be to make only what is required when it is required by the customer, the philosophy of just in time. However, many companies work on the principles of just in case. As you can see on the sample picture, that is an example of ways of overproduction. As you can notice, there are a lot of finished goods or finished products, okay? And these finished products are enclosed in boxes. So as you can notice, this is seemingly a waste of overproduction, producing more than what is required. And another example of manufacturing waste or mudas, that would be the waste of over processing. If we say over processing, it is putting more into the product than is valued by the customer. For example, we have painting of unseen areas, unnecessary tight tolerances, or cleaning and polishing beyond the level required. And it is caused by no standardization of best techniques and unclear specification or quality acceptance standards. Now, take note that the ways of over processing is where we use inappropriate techniques, oversized equipment, working to tolerances that are too tight, perform processes that are not required by the customer, and so on and so forth. So all of these things cost us time and money. So one of the biggest examples of over processing in most companies is that of the mega machine that can do an operation faster than any other. But every process flow has to be routed through it, causing scheduling complications, delays, and so forth. So in lean, small is beautiful. Use small, appropriate machines where they are needed in the flow, not break the flow to route through a highly expensive monstrosity that the accountants insist is kept busy. So the goal is to do only the level of processing to match that which is useful and necessary. So this is an example of the ways of over processing. This is already unnecessary, and therefore we should eliminate or reduce this waste. And the seventh example of manufacturing waste or muda, that would be the waste of defects. And the waste of defects is the most obvious of the 8 wastes, okay? So although not always the easiest to detect before they reach to your customers, so quality errors that cause defects invariably cost you far more than you expect. So every defective item requires rework or replacement. So it wastes resources and materials. It creates paperwork, and it can lead to lost customers as well. Now, as you can notice, this is an example of waste of defects. So in your left side, you have their rejects or defects, and in your right side, you have their good parts. So therefore, the waste of defects should be prevented where possible. Better to prevent than to try to detect them, okay? So prevention, as they say, prevention is better than cure. So there should be preventive maintenance of your machines than corrective maintenance. So how do we solve the waste of defects then? Well, one way to solve the waste of defects is through the implementation of Poka-Yoke system, and automation can help to prevent defects from occurring. And finally, the 8th manufacturing waste or muda, that would be skills unutilized. So what do we mean by skills unutilized? Skills unutilized is also known as the waste of talent, meaning failing to make use of the people within your organization. So this is actually an issue that many of our companies in the West fail to address. So we still tend to operate within a command and control environment and take little real notice of what our employees really think and what they can contribute. So your employees are your greatest asset by far and can help you to drive out many of the other ways. So as you can see, this is an example of skills unutilized or waste of talent. So you are not able to make use of the skills of your employee. All right, I think that's a good place to stop. If you have questions, please let me know on the comment section below. And if you like this video, please don't forget to subscribe and hit the bell button for the latest updates. Thank you.